Hey everybody, this is Mr. Munson, and we're in Unit 4, Congruent Triangles. We are in concept number 7, right triangle congruence. This is the last of the concepts for this unit. That means there is a test right around the corner. So we want to make sure that you are caught up and you have all the concepts under your belt, so you can show me exactly what you know on that test. All right, let's get started. All right, so just as a quick review, we have 4 shortcuts already in our toolkit for showing triangles are congruent. One is side, side, side. You have 3 sides that are congruent to 3 sides in another triangle. We have side, angle, side, where we have 2 sets of sides in one triangle that match 2 sets of sides in another. And the angle, they have an angle set that's congruent, where that angle is trapped between the 2 sides. It's stuck between the 2 sides. Then we have angle, side, angle, where the side is stuck between the 2 angles. And then we have angle, angle, side, where we have a side across from one of the angles. And so we have 2 angles with one side across from the angle. And it's not just any angle, it's across from the same angle as in the first one. We always have to make sure that we got that set up correctly. Okay, so here we are with this particular one. Let's see if these 2 triangles are congruent. See if you can look at the shortcuts there. See if you can identify if any of them, use any of those shortcuts to identify if the triangles are congruent. If not, just write not enough information. Go ahead and put me on pause and see if you can think that through. All right, well, the answer that we're looking for is not enough information, and it's really not enough information for now. You hopefully identified it as the possibility of angle, side, side, which doesn't work, right? We've already talked about that a number of times, angle, side, side not working. And so as well as side, side, angle, which is just the reverse of the same letter. So none of that works. They create actually different triangles sometimes. So what we're going to find out is that this is actually a scenario where it does work. These 2 triangles are congruent, and the key is that right angle. All right, well, let's take a look at a new theorem, a new shortcut. Okay, so this is called the HL theorem, or the hypotenuse leg theorem. And basically, just right there in the name tells you exactly what we're looking to have congruent. So for it to be a hypotenuse, we have to be talking about right triangles to begin with, right? So these have to be right angles that we're dealing with. And if we don't know those are right angles, then they're not right triangles, right? And then we have to have a pair of legs that are congruent. Legs are the sides that actually help make up the right angle. And then we also need to have the hypotenuses congruent. Okay, so there's the hypotenuse is congruent, then the legs are congruent in a right triangle. Hey, we've got ourselves congruent triangles. So in a quick formal fashion, we'll write if in 2 right triangles a set of legs are congruent and their hypotenuses are congruent, then the 2 triangles are congruent. It's as easy as that. Okay, so let's take a look, see if we can apply this. Let's look at this problem in the sense of, excuse me. So what we want to do is see if we can prove that these 2 triangles are congruent, okay? Hopefully you can identify some things that we're going to be able to just walk in and get for free. But let's take the information there and apply it to the drawing. Go ahead and put me on pause and then mark the drawing appropriately with this given information. Well, first of all, the given information is that AC and DB are perpendicular. That's code for, hey, there's some right angles down there. So I went ahead and marked those angles right by putting little boxes in them. I stagger them so they don't, get me confused of what it is, okay? And then these 2 pieces are congruent as well in the given. Now, we automatically can mark these 2 sides, the side that's in between both of them, as being congruent by the reflexive property. So, hey, that is exactly the HL theorem criteria. I have right triangles because there's right angles there. I have a pair of legs that are congruent. The legs that are, these represent the legs of each triangle. So AC is a leg in the left triangle as well as the AC is a leg in the right triangle. And then we have the 2 hypotenuses being congruent. So we get to say that the triangles are congruent by HL. Okay, I'm going to get all this garbage off the picture there. All right. Now I'm going to take you through that exact same problem But this time we're going to do it in a very formal way, kind of using this what we call a two-column proof, where we write a statement, then a reason. Okay, so here's my given information. I've already marked my drawing to include that information. And down here it says prove that the two triangles are congruent. Now, I don't need you to focus on if the triangles are congruent. We already know that. We've just shown that logically on the page before. What I want you to do is more focus on the technique of writing a two-column proof to identify this. So the first step you want to do is ask yourself, can I prove these triangles are congruent? If you can, what method would we use? Okay, so this is definitely enough information for HL. We just talked about that. So when you go to do your two-column proofs, you're going to do this like a story, right? So you're just going to do line by line by line, and you're going to make sure that you have your reasoning over on the right-hand side, that the reader would understand why you could say it. Okay, so to talk about using HL, I'm going to have to talk about hypotenuse and a leg being congruent. Well, those are terms that are used when we're talking about right triangles. So really, before I even do this, I need to also identify that I have right triangles. And before I do that, I need to show that I have right angles. And luckily, that's already going to be given to us in this particular problem. Okay, so kind of the order in which I'm going to go about doing this problem, I'm going to show that I have some right angles inside of some triangles to make them right triangles, and then I'm going to show that the hypotenuse and legs are congruent, and then I'll have that the triangles are congruent. Okay, let's do that. Okay, if you haven't already, set up your two-column proof. Put me on pause because I'm getting ready to add our lines. Okay, so first up, I'm going to show that that I'm going to start my story talking about the lines being perpendicular so I can talk about right angles. Okay, so I bring in the given fact, AC is perpendicular to DB. Given. Next one, next line. Angle ACD and ACB are right angles. Put me on pause and look back over at the triangle and see if you can identify those angles and if you agree with me that they are right. And the reason I'm saying that they're right is because of a definition of parallel or perpendicular lines. Whenever two lines are perpendicular, they form right angles. Third line, triangle ACB and ACD are right triangles. Well, definitely, because they have right angles in them. I just said that. And so that means that they're right triangles. And the reason I know that that makes them right triangles is, well, that's the definition of right triangles. They have a right angle in them. All right, line number 4. AD is congruent to AB. That's given. And not only is it given, but if you take a look, I have that H over there. And so it's good customary technique to, as I'm trying to do an HL proof of how these triangles are congruent, when I identify a piece of it, I'll put it in circled form like that. So that line right there is clearly, I got the hypotenuse is congruent. Next line. Well, I have AC is congruent to AC, and that's by the reflexive property, and that's the pair of legs I need for an HL congruency. So there I go. I'm ready to go. I can tell by my circled H and L that I've proved all the facts that I need to do a hypotenuse leg theorem. So here's my triangles, and I can say that they're congruent by HL. Okay, so let's take a look at another two-column proof, but this time I'm going to really ask you to write this proof on your own and kind of think it through. So to help you, over on the right-hand side are the statements and reasonings, not in any particular order. I will tell you on the left-hand column, if you see one there, on the left-hand column over here on the right, this is going to be all your statements, okay? They're not in any particular order. These here go on the far right-hand side as you develop what the kind of proof it is. These are the reasons that you're going to write down over on the right-hand side of your two-column proof. So what I want you to do is put me on pause in just a moment. See if you can write this proof on your own. It's only 4 lines, and see if you can do it. So the first step you'd want to do is take the given, throw it into the drawing, figure out how you're going to prove the two triangles are congruent, and then start writing your proof. Now, if you're stuck, come back and I'll give you some hints. Put me on pause. Well, here's some hints. So I've taken the information there. Of course, I know that these two angles are congruent. That would actually be the first thing I might do in the drawing to kind of help me figure out how I'm going to prove these triangles are congruent. That's a good deal of information there. Again, see if you've walked to this place with nothing in your two-column proof and you needed some guidance, see if you can put me on pause and then really challenge yourself. See if you can think through what statements need to go in there. Just think logically how you'd prove this thing uh, to be done. Now here's a big hint. It's a side angle side proof. Okay, so here's a line that should be some information about some sides being congruent and so on. So put me on pause and see if you can come back in just a few minutes and check your proof. If you have it completed, just let it run and you'll see the answer. All right, there's your proof. Okay, so here I am saying some sides are congruent, then some angles are congruent, and some sides are congruent. And by side angle side, these triangles are congruent. All right, I hope that you were able to do that on your own, or at least with a little bit of guidance, you were able to get there. And if you did, be very proud of yourself. You've written your first two-column proof. And if you were able to do that entire thing on your own, please let me know. I'd love to hear and cheer you on that you got it done on your own. And even if you had to get a little bit of help, just come and let me know. Hey, Mr. Munster, I did that two-column proof. By you being on pause, I was able to do it. I'd love to hear about it. Let's move on. Okay, hey, you know what? I have made a mistake on your do it problems which are coming up. I accidentally put in, I think, F here on your do it problems. It should say L. So go ahead and replace that on your do it problems. It should be L. And so let me just talk about this real quick so you can get it done pretty easy. So I have two hexagons that are congruent, right? This is the congruent statement for these hexagons. And so basically, remember, if these two polygons are congruent, then their corresponding parts are congruent. So if I look at angle C right here, it should be congruent to angle J, which is in the same exact spot of the series of letters. So I know angle C is equal to 38. So that tells me that angle J is also equal to 38. So I can set up an equation, solve for that x, but remember, I'm looking for what the measure of angle L is. So think that through, okay? Make that change on your do it problems when you see them here in just a second. All right, that's it. Hopefully you had a summary written, and let's go ahead and scroll through these do it problems, and you're on your way. Now the first problem A, or problem number 1, has two parts to it, A and B, and those are your HL stuff. So here's problem number 2 and some review problems. If you don't know how to do these, then you're the exact reason they're on here. I want you to go back and look at either previous videos or notes or formula sheets to make sure you know how to do that. All right, that's it. I hope you have a great day. Take care.